Hey there, it's nice to see you. Welcome to our video on graphing a polar equation, and here specifically graphing the polar equation r is equal to 4 times the cosine of 3 theta. Now remember, if looking back at the tutorial, the polar equation of this form gives us what's called a rose because it has petals. And when the coefficient in front of the theta is odd, you'll have the same number of petals as that coefficient. That's the case we have here. Our coefficient in front of theta is 3. 3 is an odd number, so we will have 3 petals. If the coefficient in front of your theta were even for a polar equation of this form, then you would have twice as many petals as the coefficient. What I've done so far is set up a table of values for inputs of theta and the outputs of r from our equation. So just try to going through this couple of these. If theta is 0, 3 times 0 is 0, cosine of 0 is 1, 4 times 1 is 4. So I have the polar coordinates for that is my r is 4, my theta is 0. When I plug in pi over 12, 3 times pi over 12 is pi over 4. The cosine of pi over 4 is the square root of 2 over 2, and 4 times the square root of 2 over 2 is 2 times the square root of 2. So that point is 2 times the square root of 2, comma, pi over 12, etc. So you could do that for each of these values along in the table. But we want to focus on graphing these points and then drawing the graph of our polar equation. So remember, when we're graphing the polar coordinates, even though the polar coordinates are listed r comma theta, we think about turning towards the theta first and then walking out the r. And remember, if the angles are positive, you go from the polar axis up and around. If the angles in another situation were negative, you would go down and around. Also, with r, when the r is positive, you walk in the direction that you are facing from the theta rotation, and then if the r is negative, you would walk backwards from that. So to graph r 4, 0, we have 0 facing the polar axis, so that coincides with the positive x-axis, and then we walk positive 4. So 1, 2, 3, 4 is our dot. So normally I don't put those other little slashes on that, but you can't see the movement of my pencil, so I wanted you to see that movement to get to that first dot. Now 2 times the square root of 2 comma pi over 12. So you're going to rotate facing the pi over 12 mark on the polar graph, and then radius is positive 2 times the square root of 2. Well, the square root of 2 is approximately 1.414. Multiply that by 2, you get 2.828, which is just shy of 3. So along that pi over 12, we're going to go 1, 2, and just shy of 3. So right about there. Now the next one is 0 comma pi over 6. So I'm going to face the pi over 6, but I'm not going to walk forward off of that. So that's really at the origin, at the pole. And then the next one is negative 2 times the square root of 2 comma pi over 4. So this is where we're going to do our rotation to face the pi over 4 line, but instead of walking forward on that, we are going to walk backwards. So just to see it a little bit better, our pi over 4 is here. So that's the pi over 4 line. And as I face it towards the pi over 4, I'm going to take steps backwards, just shy of 3. So 1, 2, just shy of 3. So there. And now at pi over 3, think about the pi over 3 line here. Face pi over 3, but walk backwards 4 steps. So we have 1, 2, 3, 4 right there. Next we have 5 pi over 12 with the negative 2 square root of 2. So the ordered pair again is written as negative 2 square root of 2 comma 5 pi over 12. So we're going to face the 5 pi over 12, but we're going to walk backwards on that. And we have a 1, 2, just shy of 3. And then when pi over 2 was plugged in, we got a 0 out for our r. So we have 0 comma pi over 2. So when we're facing pi over 2, we don't go left or right. So it's just at the pole. Or sorry, we don't go forward or backwards. So it's just at the pole. Next up, we have when 7 pi over 12 was plugged in, 2 square roots of 2 came out. So we are going to face the 7 pi over 12, but I have a r that's positive again. So once I face the 7 pi over 12, I'm going to walk forward towards 1, 2, just shy of 3. When I face 2 pi over 3, I walk out 1, 2, 3, 4. When I face 3 pi over 4, I walk out just shy of 3. And when I face 5 pi over 6, I am at 0 again. Now notice if I'm facing the 11 pi over 12, I need to walk backwards the negative 2 square roots of 2. So just shy of 3, that point is here. I will kind of look at highlighting that. So at the 11 pi over 12, that is this one. And so we have that point. And then now as we graph these, it's very similar to a spirograph. So if you've ever done that spirograph where you put your pencil in the little holes and the gears of it help you draw like the spirals, that's kind of what you want to do. You want to go through these points as they occurred as we went across. So we have these points were what we got, and then we went through this set of points, through the pole, through this set of points, through the pole, and then these last set of points. And there you have the picture of the polar equation r is equal to 4 times the cosine of 3 theta.